So we're going to be working on question 3, which is based on constructing efficient frontiers. So the first thing we're going to need to do is select 10 listed US equities with at least 5 years of monthly data history, where that monthly data history just refers to the stock prices. And we're going to need to make sure that they come from at least 3 different GICS sectors. If you're not familiar with what the GICS sectors are, follow this link that's contained within the assignment task sheet, and that will take you to where you need to go. Then you'll have to tabulate your selection. So putting a table in that states each of the different companies you've chosen with just a line below that states clearly which GICS sector each belongs to. Now, the next step of the problem is to download their adjusted close prices from Yahoo Finance on the monthly basis, and then we're going to calculate monthly returns. This does say that you are able to use Bloomberg, whichever data provider you like, but Yahoo Finance is obviously going to be, in this case, probably the most accessible one. So we're going to do this in Excel. What it's going to look like is we're going to download the data, then we're going to calculate the monthly returns. And clearly here we're listing out the company, its GICS sector, and we're also just including the average monthly returns based off our history, our holding period, or our 5 years of data. And then we're also representing the standard deviation. Going back to the assignment, we are going to now, for question 1 here, need to show the correlation matrix of our selected stocks, and then using that correlation matrix, which pairs are most correlated and which pairs are least correlated. So going back to our Excel file, we're going to set up our correlation matrix. So it's just going to be a 10 by 10 matrix where each position within the matrix represents the correlation between asset 1 and asset 1's returns, or asset 2 and asset 1 returns, and so on and so forth. We're going to calculate this using the Correl function in Excel. And the best way to do this is to make sure that the first array you enter is the array in the column. So what that means is the first number that you set of numbers you enter, the first array of returns you enter is this company in the column, and we won't press F4 when we select that stock. But now the next one that we select, our second array within the Correl function, we're going to select the array that lines up with the asset in the row that we're in. So in this one, we're in row 1. So we're going to select column 1 in the returns table, and we're just going to press F4. The reason we do this is just you can keep that same approach and you can do that the whole way down. And then you can Control R the formula across, and that will just save you a lot of time. Or if you want to keep your formatting alternatively, you can just paste the formula. And then using this correlation matrix, you're then going to be able to identify which asset pairs have the highest correlations and which ones have the lowest correlations. Now we'll move on to the second question, which is construct and graph the efficient frontier of your selected stocks. Hint, you are allowed to short sell stocks. So what we're going to do here, firstly, we're going to need to calculate the annualized returns of each of our stocks. So that's going to involve taking the monthly returns that we have in this table and converting them to annualized returns. And we're just going to be using the average return. And this is going to give us our expected annualized return for each portfolio. So the way we're going to do that, following the formula, using the average, drag that across. And then below, we're just going to get the standard deviation. Now that we have our standard deviation alongside our correlation matrix, we can actually calculate the covariance matrix as we have here. It's just going to be the same 10 by 10 matrix. Now that we have our covariance matrix, as well as our expected returns, our standard deviation, we can move on to calculating our portfolio expected return. So firstly, we're going to need to set up each of our weights in our portfolio. And because we have 10 assets, we're going to assume our portfolio weights at least are equally weighted, so 10% in each asset. And we're just going to put this check in, which is just making sure that our total portfolio weights sum to 100% so that we're fully invested. Now we're going to calculate our portfolio expected returns, and that's just going to be the product of the weights matrix and the expected return matrix. Alternately, you can just take the product of each weight by the expected return, which is exactly what this is doing. But obviously the matrix is a faster way to do so. Now we'll calculate our portfolio variance, which is just going to be the product of the transpose of the weights matrix multiplied by the covariance matrix multiplied back again by the weights matrix. And that's going to give us our portfolio variance. Then we can calculate our portfolio standard deviation, which is just going to be the square root of our variance. Now we have all the required information to construct the efficient frontier. So the efficient frontier is going to look like this. We have our portfolio risk on our x-axis and our portfolio return on our y-axis. And the way that we calculate the portfolio risk based off our portfolio return is we set out the amount of portfolio return. In this case, we want 45%, it could be 40, depending on the assets you pick, but you just want to sort of, you're getting a shape that looks roughly like this. What you're going to want to do to calculate the portfolio risk is use the solver function so that you're getting the portfolio asset weights such that the portfolio variance is the lowest level it can be given the portfolio return. So what we're going to use is we're going to use the solver add-in in Excel. So go into the data tab and you should have solver there. However, if you can't see it, go file, options down the bottom, and then you're going to go to add-ins, Excel add-ins, press go, tick the solver add-in, press OK, and it should just pop up there. So now we're going to use the solver add-in to minimize our portfolio variance given a targeted portfolio return. So we're going to set our objective here, and that's going to be the portfolio variance. And we want to minimize that, so press the min button. And the way we're going to minimize it is by alternating our portfolio weights. Now, we are going to now have some constraints. While we are allowed to short sell, that means we still have to have a total portfolio weight that sums to 100%. So what we're going to have to do is add a constraint that says the sum of the portfolio weights must be equal to 1, as 100% is 1. And then our second constraint is going to be that the portfolio return is equal to the 1% return that we want. We have these two constraints. We can just press solve, run quickly. As we see, it has found a solution, so just press OK. And now we can see our portfolio return is 1%. Our portfolio weights have all changed from the original 10%. And now this portfolio risk, a standard deviation, that is the lowest standard deviation that can be achieved while providing a 1% return. Now, it's going to hard code that in. So just paste the value. And now we're just going to run our solver again. However, we're going to change the constraint for the return. We can see that B59 is the 1% return. We want to change that now to 2%. So we're going to change it to B60. And we're going to solve it. Found a solution, press OK. Now we're going to copy in that portfolio standard deviation, paste that in. And now what you're going to do is you're just going to run through that until you've completed all of the key ones. And then you're just going to graph it using the graph function in Excel, using a line graph. And you should end up, while we haven't completed this yet, you should end up with an efficient frontier that looks like that. Now we'll move on to question 3, which is construct a portfolio using your 10 selected stocks that minimizes the total portfolio risk, showing the weights of your constructed portfolio and explaining why you believe this portfolio minimizes the total risk. So the Excel functionality that you're going to need to do this question is the exact same solver technique that we used previously. However, obviously, we don't want to give it completely away, but it just involves how you would manipulate those constraints such that you would find the portfolio that exists that has the lowest total level of risk. Now we can move on to question 4, which is construct a portfolio using your 10 selected stocks that minimizes the relative risk to the S&P 500 index. So we're just going to go, and basically what we're going to do is everything that we've just done, but we're going to keep it, the whole process exactly the same, except now we're going to set up a new table of returns. We're going to put in a new table of returns. However, we're going to make it equal the return on the stock less the return on the S&P 500 during the same period. We're just going to want to go in here. We're going to lock it onto column W. So F4 into, you've just got the dollar sign on W7. And we're going to drag that over. Dragging that down. And now we have the return between the stock and the market in that period. And now we're just going to repeat the exact same process. Again. However, we're going to use these market adjusted returns. Good luck with the assignment, and I hope it goes well for all of you.